So, good afternoon, everyone. I'm happy to have you today for the second lesson on ICT, data science, and big data for smart grids and smart cities. I suppose that at this moment, my colleagues have given you also other perspectives of ICT solutions that can be applied to your disciplines. Today we're going to go back to data, and we're going to start having some hands-on touches on the things that we have been discussing the first 4 hours and those that we are going to discuss today. I remind you that you can always ask questions through the chat here, through Slack. I see that some of you are already connected. And you can also unmute your microphones and interrupt at any moment to ask questions. Particularly today, we're going to have a little hands-on to motivate the idea of using data to do some analytics and address data science methodology. So in those moments where we are going to have like a kind of practical touch, do not hesitate to interrupt, and I'm available for answering questions, so that all the group, we are a huge group, can go step by step on the ideas that we are going to discuss. Of course, feel free also eventually, if you are not having a very nice connection, sometimes the tools that we are going to use need some bandwidth. So if you are not connected on a large bandwidth network, then don't worry. The exercises, just try to follow, and the exercises are provided online, and you can always have a try after the lesson. And if you have questions, of course, I am available for you in order to ask questions. I remind you also that this is our last plenary session altogether during 4 hours, and then there will be a laboratory session where you will be divided into 3 groups. So just go. I don't know where you have this information. I think that this in your schedule, personal schedule, you have already scheduled the lab session. So be sure that you all have a lab session scheduled so that we can meet in a more practical session for the lab. And if you have questions, then do not hesitate to contact me and ask about the session you are inscribed in for having the lab hands-on. So in order to start warming up the session today, I just wanted to be sure. I mean, it's been like 2 or 3 weeks since our first session. So I wanted to have a short wrap up on the first lesson, just to be sure that all of us are on the same page regarding this part. During the last session, we started motivating everything we are going to do together with me under the umbrella of datification. Remember that datification is this possibility of sensing reality and turning all possible observations that can be observed through electronic devices from reality into data. And once we have this data, it is possible to have a quantitative and an analytical approach towards this data that has been collected in order to make decisions. So the key aspect and the ultimate objective of all the things that we are going to do in these lessons is that everything that we do must help for clever decision making. And a clever decision making is the one that it's not empirical, that it's based on observations, on data, on operations, quantitative operations applied to this data that provide us input in order to make our decisions. And we are able to explain where our data come from, what is the quality of our data, what are the processing operations that we did in order to have insight about the observations that were analyzed through data, and then how we used these results in order to make our decisions. So it's like having a track of the way we led to some decision. And this is the ultimate objective of dealing with this data. So please keep in mind that this is the background of all the activities that we're doing, and the general name and the buzzword, if you want, that represents this, this approach is datification. Now, out of datification, it's possible, we explained in the first lesson, because there was a previous trend regarding what we call the big data trend. And the big data trend referred to the fact that we have collections of data, and these collections of data somehow put to the limit the data management, storage, and data processing architectures that we have used until now. So remember that we talk about big data when we have collections that are difficult to be managed on single machines and traditional databases, and that require new generation of tools, of methods and technology in order to collect them, to process them, and to analyze them. And then in the back, in order to have a first step towards the processing and the management of this data is that regarding the way we put in practice these methodologies is like using programming models like parallel processing and distributed storage. So datification first, then big data, have in mind what the big data definition is, and then remember that big data is normally characterized by several properties. And in fact, today we are kind of stopping to talk about big data, and we are rather just talking about data collections that have different properties, and these properties guide us on the way we can exploit these data collections. And remember that these properties are the V properties. At the beginning, there were 3 V's, and then suddenly appeared 5 V's, and today we have many V's. The first 5 are those that have to do on the way we process the data. The others are in general related to the use of the data, and since we are trying to remain general in the data processing perspective, even if we are going to focus on specific aspects of smart cities and smart grids, we are going to talk here about 5 of them. The volume, which is the one that is mostly used because of the word big, so you have the summit of the iceberg, and people tend to talk about volume, even if volume is not the biggest issue of data collections. But anyway, we have to be aware of the volume. There's velocity, which refers to the production rate of the data. For example, in smart grids and in smart cities, velocity is an important characteristic of the data that we have to deal with in these disciplines, because we use sensors and many different devices that sense the city or the smart grid and gets out information and data in order to process it and have insight about this context. Then there's variety, again, in the context of smart grids and smart cities, even if there has been a huge effort done in order to have a generalized technology, or at least representation of data. There's a lot of variety that comes from the format. There are proprietary formats coming from specific devices. And so we have a great variety of data formats and data types. And this has a huge impact in the way we are going to prepare the data in order to process it. And so variety, I would say that velocity and variety are those that really characterize the type of data that you use in your disciplines. Then, as we said, there are others. There's veracity, which refers to consistency, value, which refers to a monetary or at least non-monetary property that gives value to the data. And there are all others like variability, which refer to inconsistencies on the data that is quite related to veracity. But anyway, as I said, volume, velocity, variety, veracity, and value are the 5 that we are going to refer to in the kind of problems we are going to address in this lesson. But anyway, it's important that you know that there are other V's in the model. And again, very important is to think about properties, because they guide the way we are going to implement solutions based on the data. Once we talked last time about big data properties, then we started to say, okay, we are happy, we have the collections and they have these properties, very nice, but how do we deal with them? Sorry. So an important thing to consider is that in fact, we have to maintain these collections in order that people can use them for their particular projects. So an important aspect of this maintenance is called data curation. It refers to the way we manage data collections across their life cycle. And the very key issue about data collections is to know what is the content of a data collection without having to analyze record by record or item by item and trying to figure out what the data refers to. So normally in data curation, the idea is that you extract as much metadata, as much descriptions as possible, so that someone that is going to use the data collection can have a general overview of this. And last time some of you followed the data lab exercise, and I gave a collection without telling you exactly what its content was. We just knew that it represented the saga Game of Thrones, and then you saw that when you upload this data to the data lab, the first thing that it does is, of course, it has generic structural metadata. For example, it says the format. In our example, we use CSV, so tables, records, and attributes. So it tells you the size of the files, the name of the files, and these technical aspects of the data. And then it generates a set of statistics going column by column and going through the values and aggregating the values in order to have this quantitative understanding of the data. And some of you at some point asked me, well, okay, it's fine to have this quantitative information, but what do I still don't know what the data represents. And this is the aspect that data curation can complete, either by making humans intervene and say why did they produce the collection and what did they observe, or eventually applying other techniques in order to figure out what the content refers to, which is a very challenging problem. Normally what happens is that providers of the collections have textual descriptions about the data collection, then you have the quantitative representation, and you will see today that we are going to start going through data science methodology, that it will be very important. This quantitative information will be very important in order to decide how we can process and get insight of using these collections. But anyway, regarding data curation, it enables data discovery and retrieval. It maintains the data quality. It adds value by adding metadata and complementary information about the content of the data collections. And it makes it possible to reuse it over time, reuse the data collections over time. So you can associate this notion with the notion of the library. When we used to go to the library, if it was possible to ask in the corpus of the library about books, in that case, that have to do with some topic that contain specific information, or the type of corpus of the library, their journals, books, etc. So it's a kind of, the same idea is applied to this data curation, and you have collections of many different types, and then a curation system can provide you help in order to choose the data collections that you might need in order to develop a data science project. For the story, for example, the National Library, the British Library, for example, is starting having these kind of projects for people that are willing to do data analytics projects. See, so you have librarians that suggest different data collections with different qualities for a given requirement. And then another aspect that we saw last time is the type of use that we are going to have using data collections. So, and a very important thing to consider is the degree of rawness of the collection. You can either have very data in a very raw status, and then data that have been very curated, and depending on their degree of rawness or the degree of curation, you can have different exercises performed on them. And what I said is that in this lecture, what we're going to address is the moment where data collections are more in a very important degree of rawness. And so we are going to learn how to explore them, how to get insight, hindsight, insight, and foresight out of this data. And at some point, we're going to produce curated data, and then others will query them in a very different manner. But again, what we're going to go through is more in this sector of the data spectrum. So in the case of the lecture, it is important that you understand, that you make sure this, for the time being, we have started doing this, okay? So while we go on through the lecture and through the lab, we are going to see examples of these three. And at the end of the course, it will be important that you can say, when I'm doing data exploration, I can ask these kind of questions to understand the data. And then when I'm looking for insight, I can perform these kind of operations to get these, to respond these kind of questions. And insight again and foresight again, so that for every aspect of this spectrum, you know what you're looking for and what are the type of tools that you can use in order to do this, to achieve this objective. So this is very important that you keep in mind for every of the four kinds of processing that we want to do, these collections, purpose, and methods to achieve such kind of objective. And again, we have started only here. Then what we did is that we said that since we are talking about huge things, huge in the sense of requiring important computing resources in order to deal with data collections, we need architectures that provide us with such important resources. So the cloud is an example of architecture that provides us enough computing, memory, and storage resources in order to deal with collections that have B properties, okay? So it is very important, just maybe not for the core knowledge of the lecture, but rather to be sure which kind of tools are available on top of cloud architectures that you can use in order to play with data, okay?
Hi, I have one question.
Tell me.
So here in the platform as service, one example is databases systems.
Yeah.
It will be like the MySQL, all
Exactly.
those.
Yes.
But so my question is, which kind of data, like, why would I enter in MySQL and what would I be looking for in this kind of databases?
Well, in fact, you have to refer to this spectrum. When you're
Yeah.
talking about MySQL, Oracle, and things like that, in fact, you're talking about very curated data. Okay, so if your data has gone through different processing, well, it started in a raw condition, and then you started processing it, etc., until you have a curated database, then you use, for example, MySQL or a NoSQL storage in order to store your data.
Okay.
You see, and when you, for example, we in Kaggle, in fact, we were here. We use these CSVs, which are records. And so we decided to use a normal storage, it's a file system, in fact, in order to archive them.
Okay.
You see?
Yeah.
And then with regards to resources, well, in the Game of Thrones example, it can also work in your machine. But if we are talking to about volume, for example, then Kaggle would be interesting because it provides a lot of storage.
Okay, so MySQL will be like, it's like if you have a data store in Excel, the next, like, it's like, will be like kind of a format or something.
Yes.
Okay.
In fact, when you stop at Excel, you have, well, you already know that if you have columns and you more or less know what do these columns represent, okay?
Yeah.
But when you design, for example, a relational database, you add properties. For example, if you talk about relational, you are going to ensure that you don't have, you avoid having null values as much as possible. You respect normal forms. You avoid having repetitions on the data, this kind of design aspects that imposes, for example, a relational database. Whereas in Excel, you can have repeated data and it's not a problem.
Yeah, okay,
You
okay.
Mm-hmm.
Thanks a lot.
You're welcome. So, but anyway, we don't, we can have different, of course, I presented the things in a separate manner, but the world is not perfect. So you might have pieces of collections that are in row. And for example, as your colleague asked, pieces of collections that have already been curated. So you have to deal with different tools in order to manage your data. So you need, and if you are talking now about volume, and if you are talking about variety, so you need an infrastructure that supports all these charts. And this is why we tend to use cloud solutions or solutions that provide us with these resources requirements in order to make life easier and possible, okay? So the important thing to be said with respect to the cloud, I'm referring to the cloud because all the tools that I'm going to present for you to use will be based on the cloud. I just tell you that the cloud is not the only solution for this. Okay, there can be other solutions, but I'm going to focus on these. And I think that for people that are not computer scientists, the cloud is a good way of having an understanding on how to get resources in order to process your data. Okay, from our point of view, the key issue is I need resources. I need a lot of storage support. I need computing capacity, and I need main memory so that I can upload my data for the programs to run. Okay, and we will see that normally all the programs that we are going to apply to process data are greedy, which means that require a lot of computing resources. So I need a solution that provides me with this. The cloud is a good example of an architecture that will provide me with these resources. And a very nice thing about the cloud is that it is elastic. So if I need moderate resources requirements, so it will provide me with this. And if I increase my requirements, it will elastically provide more resources. And if I, at some point, want to go on in-house tests, I can go back to less resources. And this is a very interesting aspect of the cloud because you don't need engineers to prepare you with the adequate machines. It's done by this provider. And this is interesting because you will see that we have a lot of decision making to do for choosing the models, understanding how we are going to use the data, what is the data, etc. So we can focus on our problems, on our analytic problems, and leave the technical problems to the infrastructure. So the thing to keep in mind is that it provides different services. So anything that you use from the cloud is given by a service. So this is the unit of exchange that we, in the way we use the cloud. You have infrastructure, you have horizontal solutions, like the platform as a service, for example, database systems. You can also have file systems. You will see, for example, in Kaggle, when we explore our CSVs, in fact, what we're doing is we have a file system in our Kaggle account. And so we can organize our data in this file system. And if we need other things, it is possible to have. And then software as a service, which are dedicated applications, software that you can use in order to address other aspects of data processing. So Very often when you talk about big data and when eventually you talk about data science, many solutions talk about the cloud, and it will be our case. And then on top of this, for example, you can have services, applications like that are called data labs. And data labs provide us with all the necessary services in order to deal with our data collections. And last time, what we saw is the example of Kaggle. So it is very important that in order to make the association with the cloud in a generic manner and then have the data lab as a software as a service that can be used in order to deal with collections. This is the stack that provides a data lab. So you have the data that are stored. You can use both things. You can use your own disk and then put some of the data on the cloud. And the data lab works like this. Then you have storage support to deal with this. For example, you have your file systems that can let you go through the files that you are storing in the data lab. And then you have different tools in order to have more evaluated processing of the data, to do analytics on the data with programming languages dedicated to them. And then you have other tools like versioning your, for example, I suppose that you started playing a little bit with the example of the data lab that we did last time. If you see, it is possible to version your data collection. So I have a first version of Game of Thrones, then I have a more complete one, or the one that has been tagged, or some a version with a different license, for example. And so the data lab provides us with a versioning capacity so that we can deal with different versions of our data. And it is also possible to tag the data. And you already must have seen that tagging the data is very important if you want to share them, because normally we do not interact personally with the one that produced the provider of the data. So if it is labeled, it will help us to use it for other purposes, for example. Okay, so this was the first lesson. And now we can go on. And we are happy we have the data. We have tools in order to manage our data, different formats, and then quantitative insight of the data, and then so what? Well, in fact, one of the uses of all this data is data science. So data science provides with the methodologies in order to, based on the data, perform different analysis on this data, okay? So when talk about data science, we talk about, first of all, about a methodology. As any science, it has its own methodology, and it is an example of data-centered science. So the core of all the the tasks that we are going to perform under the umbrella of data science will be data, okay? It's data with the properties of big data. We are going to do analytics, and therefore a second element associated to data science, first is data and the other column is algorithms. We're going to use different analytics algorithms in order to play with the data. And of course, we are going to use tools. And these tools, the idea is that they should make our life easier in terms of technical issues to address. So the idea of the tools is to give transparency as much as possible on technical computing configuration so that we can really concentrate on the algorithms and on the data to which we are going to apply these algorithms, and of course on the kind of questions that we want to answer with data and algorithms. I remind you that in any experimental science, you must remember it from all your studies, you start either with research questions or with a hypothesis. And you are going to perform experiments in order to answer your research questions or validate or contradict your hypothesis. Okay, so the methodology will help us to do this, answer research questions and validate or invalidate our hypothesis. So, definition of data science, it is a methodology by which actionable insights can be inferred from data. It includes many, well, the methodology, in fact, has elements of many different sciences, and all of them are confluent in the methodology. There are important, like technical ones. You need to, well, understand data engineering, how you deal with it, you engineer the data in order that you can run experiments on it. It is important to consider data governance. The example of Kaggle, we saw the license, that data collections are associated to licenses. In fact, for academic issues, we are using open and data collections in a very open manner, but in fact, it is important to consider whether we can use the data or not, or whether the data have associated constraints on the way we can use them, okay? For example, today, if you are using data regarding people, you have to respect GDPR constraints, privacy, for example. So it is important that to add to the methodology data governance, data engineering. There are also business models because, again, we're using free data collections, but normally data collections are controlled by a business model. So we have to consider this in the whole methodology that we apply in data science. And then other things like ethics, which are very important in order to run experiments under the umbrella of data science. The objective, as I said before, is to produce belief informed by data to be used as the basis of decision making. So I insisted at the beginning of this lesson, so just keep it in mind. So it's a kind of a generic definition. Now, there are many strategies. So this is a general methodology, but in fact, it can be specialized for different purposes. You can try to probe reality. So you're going to answer questions like, what is the best button size and color? If you are, for example, designing a user interface. And the only way, well, the way we know is that we are going to ask many people which are their preferences, and then you are going to gather this data, and according to these answers, you will decide which are those that are best fitted to a certain community. So you're going to probe reality. You are going to discover patterns. You are going to predict events and understand people in the world. Okay, so these strategies, the different strategies that you are going to use on a data science context, have to do with the previous slide, this one, the one that this one, where it depends whether you are just exploring, having hindsight, having insight, or foresight purposes in order to deal with your data. So this is quite related to the kind of objectives that and strategies you're going to apply when you do data science. And the thing to consider is that there is a workflow in order to perform any of these strategies. Of course, you have to collect data. You must know that each of these phases of the workflow is a world in itself, okay? We do not collect the data as like this without any methodology. There are methodologies in order to collect data, for example, okay? In this course, we're going to have a generic objective, and we are not going to address data collection strategies. We're going to suppose that someone collected the data properly and that we have access to data collections. So we are not addressing this. So then a very common way of approaching to data collections is through visual exploration. If you remember with Kaggle, all the metrics, the statistical metrics that it provides when we upload our data collection are visual. Okay, you have the distribution of the values, you have colors in order to say which data are valid or not, whether they're missing or not, etc. So this visual approach to explore the data is a very important aspect, phase of the workflow. And again, here, the visualization is, again, a huge world. We're just going to use classic things used normally in statistics, but I will show you eventually examples of solutions that really work on visualization to in the different steps of the data science workflow. Since we are talking about rawness, if it's raw, normally data have some issues. These issues can come, for example, from the way data are collected. For example, if you are using sensors, if a sensor is not working well, or if it's running out of battery, or if there was a connection problem, a transmission problem, so data can be corrupted. And it is important that when we want to perform analytics, these data are clean, that we understand where the corruption comes from and whether we can do something about it. And so there is a huge phase of cleaning and transformation. And transformation means it's very related to the kind of analytical model that we are going to use. For example, it is very often, we will see today in an exercise that we are going to do, that we use, and you have seen that in Kaggle, that we use statistics in order to explore the data. Yet for applying statistics, and particularly statistical measures, it is very important that data is clean. For example, having many null values and performing average, for example, it's not a very good idea. So we have to understand what do these null values represent and whether we can extract them from our measures in order to have a more representative average value of the measures that we are studying. When you apply regression, for example, your data must have a specific, your values must have a specific distribution. So there is we need to transform them in order that we can use, for example, statistical models in order to do analytics. Then once we apply models, a very important aspect of the data science workflow is that our results are not the truth with capital T. It just gives results with respect to the data that we have used for analyzing our phenomenon. Okay, so and that's one thing, and the other is that since we are going to not, since again the data have, for example, specific problems that we clean, then we, for example, we can perform operations in order to look for specific distributions of the data. So you see, you are going to transform and perform operations on the data. So eventually we induce to some errors, and we have to validate to which extent the model that we have represents reality. Okay, so we need to validate the model. And so a huge aspect of the workflow, once we have models that represent the phenomenon that we analyze through observations, is validation, and this you know from your statistics lesson, so I don't have to maybe to insist a lot of this. But what is important is that for modeling and for validating, I often use exploration, visual exploration. Okay, so that again in your statistics courses you have seen this. Visualization is a kind of very useful tool in order to do this kind of analysis. And once we have done this and went back and forth with our models, etc., then eventually we can say that we have a solution, that we have answered our research questions, or that we have validated our hypothesis. We have to understand interpretation is a very important element of the data science workflow. I can generate many models, but if I do not interpret them, then, well, they're there, but they are useless, okay? So interpretation is very important, understanding, and this has to do with the multidisciplinary characteristic of data science. I can be a computer scientist and know algorithms very well. I can deploy my solutions on huge data collections running on the cloud with all the parallel processing that you can imagine. Very good. Once I have the model, if I do not know the context in which this model is going to be used, the model is useless. And in order to be able to interpret, I need the discipline in which the problem is inscribed in order to have an understanding. So understanding is done with other people, with different communities, in order to have a solution. And then eventually you can deploy the solution. Okay? For example, if you have a look for on your if you have watches, smart watches, and you are collecting your personal data on health data, for example, then they apply data analytics, they apply different models, and the solutions that we have running on our smart devices are deployments of applications that went through all this process. And so we're happy, and we know that we are very healthy because we sleep well and we have a good VPN, for example, during the COVID. These kind of things, we have them deployed on applications. Okay, so this is a kind of workflow, a very generic one, because it doesn't say which are the techniques that we apply for every step. This depends on the specific product that we are addressing, but this is the thing that we must have a schema, no? So considering this schema, we should know at which level of the workflow we are, and then I will present some of the techniques that we use in the different phases of the workflow, and then you can develop data science solutions. So we're going to see how could we apply this kind of thing on an humanities example. Some of you that were not in the whole session of the last session thought that this had to be done like a homework. In fact, what I had thought of is that we run it together and that I can comment and explain through this example all the different aspects that I have been talking about in this first part of the lesson, okay? So again, the results, you can create a word or a text and you can give answers to these results, and these will be extra points for the grades. And this is extra points because you will see it's a very simple thing. It's just to have the intuition on how analytics can be used in order to address these famous research questions on a specific problem, in this case for humanities. And I use humanities just to tease you a little bit. Of course, the real lab and the real exercises will be related to you. Okay, so in order to do that, on Google Classroom or on the other side, you have an assignment, and it's the second assignment. And I think that I have a question as well. Let me see. Okay, Thibaut, is there any way you could reposition your microphone? Yes. Do you hear me better? It went out and I didn't realize, but I'm not sure that. Much better, okay. Thank you for telling me. Otherwise, I keep talking, la la la. Okay, so it's the second one. It's first steps into data analytics. And there you have a link, okay? So if you click on that link, you are going to land on this page. Let me explain how we're going to use and what we are going to use. We're going to retrieve a novel, Doyle Baskerville's, it's Sherlock Holmes, okay? So we have the novel, and the objective of the exercise will be, of course, if you have read it, just put a cloud on your mind and try to forget what you know about the novel. Let's suppose that nobody has read the novel yet. And without reading the novel, the idea is applying statistics. We're going to figure out who is the murderer. Let me just, sorry, you were just telling me that, that the mic was off, but I didn't see the chat. I will pay more attention on the chat, but now it's fine. Okay, so we are going to try to discover by doing several approaches who is the murderer and where does the plot happen and things like that, okay? So the material, we're going to use a very intuitive tool that is normally used by colleagues from humanities, okay? So they use this kind of tool. It's an application, and the application is Voyant Tools, okay? So if you click on Voyant Tools, you are going to land here. So material, Voyant, clicking on Voyant Tools, and then the novel. I use two types of formats, and Voyant can use either of them. I don't know where you are working, so if you don't have, for example, Word, then you can use plain text or the opposite, okay? So this is why I put these two input formats. So what we are going to do is we're going to charge the novel to Voyant, okay? So this little tool that will help us analyze the content of the novel. Now, from the point of view of data science, it's not a novel, it's nothing, it's just text, plain text, okay? We know nothing about it. That's the point of view of this data science exercise. So I decided to use Word, but as I said, if you're using plain text, you can either use your plain text and do and upload it, or you can copy paste and put it on this formula. Okay. Well, I'm going to use Word. So I told it to upload my input data. And I have to wait a little bit because, of course, I have connection issues. And look at this. What Voyant offers is different views of the content of my document, okay? So the first view is a cloud of words. And as you remember, a cloud of words is all the words that are contained on a document, and those that are more frequent appear in bold and huge. And then those that appear less, well, they are smaller and not bold. Okay, I have a question. Go ahead. Do I have a question? No? Okay. So that's this little window. The second window, in fact, what it does is it provides us with the real content. Okay, so it starts with chapter 1 because the first thing that appears in my document is chapter 1, but you can go and go and go through the different elements of it. Okay. The third window gives some statistics about different terms. We're going to see how to use them, okay? The first thing that it does is, if you see Holmes, Moore, said, and sir are the most frequent terms that appear also here. You see, you have sir, said, Holmes, Moore. And it uses at first these ones, and it tells how often they appear across the 10 chapters of the novel. Okay. Questions? No? I have someone with the mic open. And I tend to think that there are questions, but if there are not questions, okay. The fourth window, then it says, it counts the density of the vocabulary, the mean of every word per phrase. So there are per phrase 15,6 words in in every sentence, and then the most frequent words, which are those that appear here and that appear here, and it counts. And then this window, you can have samples of the text where you have the frequent words. For example, Holmes, and there is pieces of the text where the word Holmes appears, okay? So this is the general explanation of the of what you get at first when you upload the document. Now let's go and see what do we have to do in order to answer our question. So the idea here is that these 7 questions, of course, are questions provided by a specialist in literature that said, how can we figure out who was the murderer of in the plot, okay? But if you were, and this is, if you are a data scientist, in fact, you need this input in order to go and perform the analysis of the document, because if you are a data scientist, normally you cannot be specialist in all the areas that might be, in all the data-centric sciences that might use data in order to do analytics, okay? So I have a colleague who does digital humanities, so she provides us with these questions that guide us on the steps to address and perform our analysis in order to get to the answer, okay? So some of these are just instructions to use Voyant. So the first one is you have to hover the mouse on the menu above the word cloud to find the button define options for this tool. Okay, so we are going to start, what we're going to start to do is that to try to extract only representative information out of this cloud of words, okay? Because if we have too many terms in the cloud, well, it is impossible to explore the content of the document, okay? So the objective will be to get rid of unnecessary words and keep only those that might give us clues in order to understand the content. So if you hover the mouse, you're going to have this. You see this little button? So if you put it here, in fact, what you're going to do is you're going to tell the system which are the words that you are interested in, okay? So you're going to filter the words in order to have a better insight on the content. So if you click here, you have many things, but you have to do is, well, you can do this and say, I want to filter old Mr. Doctor, for example. Yes, and I forgot, you have to say the language. So I'm going to choose English because it's in English. And then I confirm. And then I wait for a while and it starts filtering the words that I said, okay? So the idea is that you perform an iterative process of word filtering in order to keep only the words that are more representative, okay? And this is the second point. Now, when you process text, there is a set of words called stop words, okay? Stop words are all the words that let us connect and build a sentence, but that do not have to do with the content of the sentence. For example, pronouns, for example, adjectives, these kind of words. So the idea is that we play, well, that you play with the cloud of words, trying to extract as many stop words as possible, so that you can only keep the words that are representative, okay? And by doing this, you have to come up with an answer to the question, where does the story is taking place and who are the main characters? So I'm going to give 5 minutes so that, well, 10 minutes, so that you can filter the cloud of words and answer this first question. Where is the story taking place and who are the main characters? So I'm going to do it also. So I can modify my list. And then again and again until you note that what you do is when you filter, it keeps the words that you say, okay? So for example, here my decision was a little bit stupid because I just, I filtered the stop words, whereas I had to filter, in fact, not the stop words, but the real words. So I'm going to go back to that more. Well, let's see. But since well, anyway. What happens if I say this? Yeah, my decision was really stupid because now I have only the terms that do not matter. Don't do this. Yeah, that's better. So well, an interesting thing that you can see, even if my decision is a little bit stupid, is that if you click on the word that you choose, here you will have the evolution of the word across the chapter. So, for example, Holmes is very popular in the first 3 chapters. Then the chapter stopped talking about Holmes, and then by the end of chapter 9, for example, he appears again, and then by the end, no. he doesn't. Okay, so I said, for example, Mortimer here. Yeah, Mortimer is the contrary. Well, it starts, he's very popular at the beginning, then it comes down, then it increases, but particularly by the end of the novel, his name appears growingly in the story. Sorry, so here, once you do this and that you do a clever filtering of the words, not like me, that my choice was not very clever, then the third thing is that we are going to try to have not a statistical point of view, but try to have a little bit of context in which the words appear. And in order to do that, you can, for example, type Baskerville in the box in the bottom right corner. So this one, bottom right corner, okay, here. And if you Baskerville with capital, Baskerville. Well, and you can Baskerville, for example, this one, and this was not well written. So what happens is that it gives you here context in which the word Baskerville appears in the novel. Okay, so it gives you the sentences in which you have Baskerville, and if things work well, you have the extraction of the piece of and the chapter in which the word Baskerville appear. And the idea, well, you are seeing that it's quite manual thing to do this. It's just the intuition on the kind of things that you can apply in order to explore the document, but it provides you with tools that will help you start identifying frequent words, then trying to understand within the text where do they appear, so that, and then with the statistics, in order that you can have some insight and then start approaching the plot, approaching the important events happening in the plot, and then trying to figure out the responses to the questions that are being asked by, in this case, someone that wants to solve the murder. Okay, so that's what you can do by extracting different the popular words that you have seen, and then try to put them into context in the text. Then what more can you find out about the plot by the characters? Then what you do is that if you have chosen some characters, you can double click on the lines and have a full extract on the central panel, which is here. You know, for example, I show you that I chose Baskerville. For example, I can choose Holmes, and then, for example, this version of Holmes, and eventually it will appear here. And once it appears here, to eliminate Baskerville. So when I have Holmes here, then I will go and see on the different chapters where Holmes appears, Mr. Sherlock Holmes, etc. And in that way, by interacting with this text with the help of this tool, the idea is that I understand the role of this character within the novel. As I said before, a kind of very useful thing is to have the quantitative frequency of the different words that I am extracting out of the text, because these words will help me see which are the characters that really have a key role in the novel. So in number 6, what it tells is that by using the same write tool, write down lower window, I can write Stapleton, Barry, Moore, and Mortimer and see what happens now. So let's try this. How do I write Stapleton? Going to copy paste, which is the easiest way to do. Open my window. And which one's the other one? Barrymore. And I can do it here too. So with the help of this, what happens is that you can see who is more popular at some point of the novel. What you see is that some of the characters, particularly by the end of the novel, become very popular. And so the idea is that out of this frequency of appearance of the characters within the novel, you can estimate that one of them might be the murderer. Okay. So I will let you do step by step the exercise, but what it's important to keep in mind with this intuition with respect to the type of analytics that you have is that by having exploration tools, for instance, in this case for text, trying to extract the representative terms within a text, then which is a frequency study, then associating these terms within the content of your data, which in this case is the novel, and then playing with statistics, you can eventually, by many iterations, you can eventually have an idea of what the content of this text is and which is the plot, which are the characters, and the role of the characters within the text, okay? And in such a way that it would be a first approach in order to try to figure out the structure of the novel, the structure of the plot, the characters, and how they, and their evolution within the plot, okay? So of course, if you are a literature uh, uh, specialist, this might be kind of shocking in such a way that a novel can be approached like this. But imagine that this is not a novel, but that you have a set of tweets about a specific topic, let's say the US elections, for example, or that you have text about the political speeches presented by different politicians, and you want to figure out, for example, which are the main worries or the main issues addressed in the different text or across the campaign, for example. So instead of reading all the speeches that are presented by these politicians, you could have such kind of approach, maybe with more automatic tools, not that manual, but in order to see these kind of trends, which are the trendy topics on Twitter, for example, running today. These kind of things you can apply such analytics in order to rank them and to see what are people talking about, for example, today or this week, or regarding a specific problem, things like that. So with less prominent exercises, with less prominent text, you can figure out solutions that can help you approach the content. I think that I have a question. Yes, Victor, tell me.
Yeah, sorry. It's pretty complicated to follow the screen you're showing us and try to do something at the same time. Can you repeat, how can you take words or numbers of the text?
Yes. So let's go back to here. So first thing is filtering. I'm going to reinitialize my cloud of words several times. So first, in order to manipulate the cloud of words, what you do is you click on I'm going to close this chat. I forget that you are looking at my real screen. So I'm going to reinitialize it several times so that I go back to the initial state, if I can. Anyway, if you hover the mouse, let's try to, I'm going to start from the beginning, okay? So since it doesn't want to so we started here. And what you did is to download the Word that I provided on the specification of the hands-on exercise. Okay? So you download this Word, this file, and you go to Voyant. You choose charge. Sorry, I hate that my browser is in French and I'm talking in English, but if you have your iOS in English or your operating system in English, you will have charge or upload, I suppose. So you can click to charge and you choose the input. And you wait for a second. So this is the first thing that you get when you upload the document in Voyant, okay? Is it fine until now? Fine, not fine? You can say
Yeah,
like
it's fine. The question is,
uh-huh.
why is not the most popular just numbers, like the number of the pages, or I don't know.
In the rule of a cloud of a word of clouds is that it goes through the text and it counts the frequency of every term within the text. And those terms that appear more frequently appear in the cloud of words, I mean bigger and bolder. Okay, this is the way a cloud of words is built, so that you can know, if you see it, that which are those terms that are more popular, the most popular within the document. Okay? So this is first done automatically. Did I answer the question? Maybe I didn't understand the question.
No. The question was how to take off the some words. For example, if you want to take off Holmes.
Okay, so you hover the mouse. I'm here, and then I hover the mouse here, and you have this little button. You see it? Do you see it?
Yeah.
Okay, so you click there. And first thing that you do, well, it says that it can automatically detect the language, but I suggest that you really choose English. So the idea with this is to get out the stop words, and the stop words are related to the language. If it's English, a stop word will be the, and, or, so on and so forth. And if you're in Spanish or in French or in another language, you will have different stop words, okay? So it's important that you choose the right language so that the system cannot get confused with the kind of stop words that you will choose, okay? So then you say modify the list. And when you say modify the list, it already has some words, you see, which are words or terms that are not very interesting and that were not considered in the initial version of the word of clouds.
Okay, so that was my question. Can you add words to that?
Yes, yes, you can. You can add at the end. Well, there are a lot, but you go back and then you say, for example, that you can do. I'm going to use, for example, morning. Well, anyway, I'm going to. It went up. I don't know why. So I'm going to. And then I don't have the word thing on the cloud of words. Of course, you can add several ones in order to filter until you keep those that are larger.
Okay, thank you. That was it.
That was it. Okay. Do I have other questions? So that one is for answering question 2. So the idea is that you add and add and add words until it is possible for you to find places, words that denote places, okay? And words that denote characters, so names of people and names of places. So the idea is that you add and add and continue adding words to this list according to what you see in the cloud of words until you keep only, or as much as possible, surnames and places names. Does that make sense? You can also tell me that it doesn't make sense. Huh? So the idea of a first approach is that you filter everything that it's unnecessary.
And what does it mean, the second row, whitelist? Does it mean like the words that they have to be appeared or searched more?
Can you repeat?
Yes, the whitelist.
The whitelist.
Yeah, under the stop words.
Yes, this one.
Yeah, what does it mean? Like the explanation.
This one says how many of the words that you have that are more. This counts the number of times that a frequent word appears. Am I looking at the same window as you are?
No, when you hover the mouse at the filtering part.
Ah, here.
Yeah.
Uh-huh.
So you go to the filtering part, and then that one, the second row.
Ah, the second one.
Step words. Yeah, that one.
These words, you can put those words that you want to keep. One is the ones that you want to filter, and the other one is the words that you want to keep.
Okay, thanks.
That's why I, in my previous try, I ended up with only few words because I eliminated everything and then I just kept 2 words. That was not very clever for my part. But anyway, in this, in the first list, you extract the words that are unnecessary, and in the second, you just observe the words that are interesting to you.
Okay, thank you.
Okay. Mm-hmm. Then Thibaut is writing. I'm waiting for his question. Ah, but don't cheat. Well, don't tell everyone. It's not cheating, it's just telling everyone important information.
You already know, I think.
Okay. So again, this is an intuitive way of approaching analytics. We are going to just use more automatic methods in order to deal with it, but it's just a teasing way of motivating the idea. What time is it? It's okay. So still have some time. I am already receiving hints about who is the murderer. And what about the place? Where did it happen? Because, you know, the murderer is quite easy to see, particularly here, no? Here it is very easy to, I mean, to have a guess on that. But then what about the place? Nassim is having a try. Was having a try. I'm just waiting for a question to be written, and then I will go on. Now, the hints on the answers. I have a question from Sami. Yes, you can write a word or a text, or, well, since this is a very simple thing to do, you can just send me an email and tell me the place and the main characters and the murder's name, and yes. When in this type of teasing exercise where I'm just motivating the ideas, you can use either Google Classroom. There's a possibility to send a document with the answers. You can use email, and then just send a simple text with the answers. For other things, I will tell you, in fact, what you're going to produce is notebooks with instructions, and then you can send the notebooks, but that we will see by the end of this session how. Okay, Sami? Okay, so I will let you finish this little exercise and eventually send the answer. And we're going to continue to more serious aspects and really do a first exercise. Note that today we're going to have a second short hands-on, and in fact the idea of this hands-on will be to get you prepared to the lab, okay? So that in the lab everyone will be on the same page with all the infrastructure ready and so on and so forth, so that the exercise that we'll be addressing in the lab, which are a little bit more challenging, you will be able to do it in a more smooth manner. So this session today, we will go back and forth from theory to more practical or practical examples. And the objective at the end will be that you all get ready for the lab sessions in the next weeks. Okay, so I'm going to go back to some slides. So if you go back here, we go back here. As I said, with respect to the, so in order to go to consider Voyant, look that we did a very simple way of collecting, but well, we collected, we chose our data collection, we uploaded it in the tool, and what we did is a lot of visual exploration. Voyant is really based on visual tools. You can also argue that these are not the best tools, the most user-friendly ones, or yes, it depends on also on the way you approach to the interface. But anyway, it provides several visual tools that let you approach through a textual content without having to go through the text and trying to understand or figure out its content. Okay, so it provides you in one shot many different views of the content of the text, and this is intended to help you do things. Then we did a kind of little exercise of cleaning because the fact of filtering and choosing the words that from our point of view might help us answer the research questions, which is where does the plot happen, and which are the characters and who is the murderer. These are our research questions. Sorry, and by cleaning the content of the text, we approach hints that can help us answering. And what we combine with the cleaning is the statistical model that helps us provide a quantitative observation of the content of the text. And we have very few validation. In fact, validation is that you send me your hints and then I say yes or no. But we have a very pedestrian validation. But anyway, in fact, what we really have is a kind of trying to understand whether the observations that we have really correspond to the content of the novel, on whether they are really representative with respect of the content of the novel. If you are readers of the novel, you could act as experts and say, well, you know, it provides you some elements, but there are other things that are missing, or the distribution of the places or the characters are missing some aspects. If you see, for example, when we say Baskerville, it provides very different versions of the word, and we have to consider all the versions of the word in order to have a better statistic that corresponds more to the content, okay? So these kind of things, an expert, that someone that has read the novel would say, you know, it is true that Baskerville appeared more frequently in the beginning, but then in the middle of the novel, in fact, this is not very representative, because in fact, Baskerville is referred to capitals or non-capitals or so on and so forth. So here you have a less representative statistics of the content, things like that. But this would we require someone that would have read the novel in order to help us to have a real understanding and interpretation of what Wayand with the tools provides. And then, well, eventually we could deploy something that says, for example, that gives an overview of the real content of the novel, and that lets people explore only the novel. Just for the reference, in fact, many exercises of digital humanities have this kind of representations. There are very nice tools, for example, for exploring Shakespeare's novels, for exploring Les Miserables, for example, of Victor Hugo, and they have a specific application where you can explore the characters, the chapters, the topics in a very interactive and visual manner. That would be having this kind of deployment that is really validated by experts, and that say, okay, if people want to have an analytic point of view of the novel, they can use this application, and this is really representative of the content of the novel. Okay, so this would be what we did in a very empirical manner with this exercise. Now, if we start approaching to the real use of tools for data science, in fact, the key is here. Which are the models and which are the techniques that we are going to use in order to clean and in order to provide models? And there, data science is collecting solutions from everywhere. You will be able to see in detail by getting the slides. What it says is that it uses a lot of solutions, of course, from computer science, because the idea is to use automatic tools in order to approach data collections. So data technology, visualization, etc. There's a lot, of course, from mathematics and from statistics and probability, okay? So for example, it is very, very often that we apply, sorry, just to tell me that we have been working for 2 hours. Linear regression, the squares theorem, time series, this kind of mathematical tools are very common to be applied in data science exercises. And the question is, given which kind of hypothesis and given which kind of data collections and given which objectives, is it pertinent to apply these kind of tools? So that's the question that a data scientist would answer, okay? It's not the mathematical tool in itself, but it's the pertinence of using such a tool in order to answer some question. So there's also Bayesian method. So you see, it's a kind of collection of solutions from many different sciences, from the past to the present, in order to provide solutions and answers to the questions. And in this sense, this science, of course, a data scientist cannot have such a huge expertise. Maybe we know how to use them, these tools, but we are not experts in all of these aspects. So data science calls for different profiles in order to, that can work together in order to get useful and representative solutions. Anyway, well, we still have to start from somewhere. And in fact, for the the classic data science experiments and the first approach, and the one that we are going to adopt in this lecture, is that we are going to combine, of course, mathematical and statistical knowledge that you already have. We're going to learn some tools coming from artificial intelligence, and particularly to machine learning, because there are some problems, or there are specific data collections that are not well prepared in order to accept mathematical and statistical methods in order for them to be analyzed, okay? So we need other kinds of tools in order to answer questions, and such tools often come from the artificial intelligence domain, and particularly from machine learning. So we are going to see families and examples of solutions that can be applied to address specific problems. And then there are some complementary things. So this is the part that we would address in this lecture. Since you are not computer scientists, of course, we are not going to address software development, because once you have answers to a problem, then you want these answers to benefit general people, general users, and there you need software development techniques so that these solutions can benefit a whole community of users. And of course, if you are doing business with this, once you have the solutions and once you have the applications, then you have to know how to build a business model in order to get profit from your exercise. But anyway, we're going to remain here, some computer science. So don't worry, those that do not like computing. We're going to have just little examples of programming, but very simple ones. And what I will insist on is on the use of tools that can let you focus on your problems rather than on the technical part of the development of a solution. Now, the principle that we are going, well, in fact, what we're going to do with data science is design experiments, like in the lab, like in the biology lab or the chemistry lab. We're going to design experiments. And in order to design experiments, we have to adopt some principles. So we are going to have lots of data. I mean, our experiments will be like on TV. They will be just to be sure that you run and you get the idea, but not lots of data, okay? But anyway, there will be enough so that you cannot address the problems manually. And the idea will be to discover patterns and models, okay? Patterns and model discovery is having insight of the problem, okay? And we are going, once we have derived patterns and models, we will test them to determine to which extent they are valid, to which extent they can be useful, eventually whether they are unexpected or not, they provide unexpected understanding or visions that we didn't have before about a phenomenon, and whether they are understandable, okay? Of course, you can imagine that for lambda people, you are not going to provide a model with statistical results. Even with some people, I mean, lambda users, maybe graphics wouldn't be a very friendly manner to present results, okay? So we need to make our results understandable for anyone. Now, what is not very nice from this is that at the moment in which we are in data science, we have to do a lot of test and learn, okay? So we have a question, we have a first guess on an experiment that can help us answer the question. We get results and suddenly we see that our results are not satisfactory. So we have another try, and so on and so forth until we declare and experts declare that our results are acceptable, okay? So at the time, there is not enough insight about the way running experiments would be less test and learn based and rather more automatic. Even if in the field people are trying to avoid this kind of thing because test and learn it's not a very nice way of approaching problems. But anyway, this is what we're going to see in the experiments that we are going to set for addressing our problems for the time being. So a lot of back and forth and a lot of test and learn. And also, you will see that all the experiments would be like step by step, you know? You will have a first approach, then and then you build on top of your solutions, more solutions, and so on and so forth, but in a very sequential manner. Okay. So this is the current state of the way you work with experiments in data science. As I said, we are going to combine statistics, computing, and solutions coming from, as I said, machine learning, artificial intelligence, and a complementary discipline, which is called data mining. So we are going to go back and forth on this kind of solutions. And then, as I said, with today's tools that are willing to address data collections with the properties we have been discussing. Of course, I'm not going to give you a statistics example. So this is very important so that you can have a clear vision of what we're going to do. We're going to feed data to algorithms that, as I said, come from artificial intelligence, data mining, and more or less. Okay, and in artificial intelligence, we will have machine learning. Some of you have certainly heard about neural networks and things like that. We don't have time to address this in this lecture, so we will remain classic in data mining and machine learning, and well, eventually in your professional life, you will have contact with more advanced solutions, but we are going to keep fundamental on this. This I have said, it's just what I've said, but in slides, so that eventually when you go through the slides, you can, and you don't have my voice, you can have the idea. So the problem with these famous algorithms is that, in fact, what they represent is families of different versions of algorithms. So here is the overview of the most popular existing algorithms coming from machine learning and in general from artificial intelligence. Okay, I'm going to include data mining in artificial intelligence for pedagogic reasons. Okay, but they are two communities, and of course from mathematics. So people doing data science today and dealing with data have to have very good knowledge on regression, because many problems are addressed with regression, different versions of regression. There you are engineers, so you have the fundamentals for this, okay? But be prepared to, and be comfortable that for many problems, particularly prediction problems, you will use this fundamental knowledge that you already have, so regression. There will be a lot, and there again, from our fundamental knowledge of engineering, we have people learn how to do dimensionality reduction. So of course, if you are observing a phenomenon with many different variables, you all know that not necessarily all these variables are representative to this phenomenon. No? So it is possible to reduce the number of variables that represent the observation, and this will ease the way we approach the problem, and particularly this will ease, in our case, the way we set an experiment in order to address a problem. Okay, so these are things that I believe that you already know, and that will serve as fundament for doing this. Again, there's a lot of regularization that you, again, have knowledge from your engineering education. And then there are other things like clustering, for example. This is a thing that we, at least in the Occidental way of understanding the world, that we do a lot, is we try to group things together and identify classes in order to try to understand something. So there are many different techniques in order to do this, okay? So clustering is a very powerful tool in order to explore data and then to provide models that represent some phenomenon, okay? There will be a lot of decision trees, and then other things. In the course, we will address clustering, which is very important. We will have an example of regression because we address to your engineering knowledge and show how this knowledge can be applied in order to address data science experiments. And then we will also have some examples that that are here, dimensional reduction, and then what else? We will not address decision trees. Oh yes, and we will eventually have some naive Bayes examples, which again addresses to your fundamental knowledge on statistics. But anyway, as you can see, this is families of algorithms, etc. And then what is important to understand is that there a data scientist would be of help, because that person would know, for example, the conditions and the technical conditions in which you can apply these algorithms, and the libraries and all the technical support that you can have in order to use and to adapt these tools for your for addressing your problems. This we said before last time. So how do we do all this? Well, let's start to have an insight on how does a data science lab looks like. Okay, so there are many toolboxes today that people use in order to run experiments. What is important to know is that normally what happens is that you run an initial experiment. It's like an industry. You run an initial experiment in-house, you know, like in a little lab, and you reproduce the conditions that you want to observe in a small size version of your experiment. You have a try on this, and once you have more or less the idea on that the experiment runs well, that it is promising, that you get promising results, then you scale. And scaling means using more data and eventually trying other algorithms that can provide more complementary results on what you tested in-house. And once you have this, then you can really go to deployment and start working at scale with really enormous resources, with really a lot of data. And then an important thing is to maintain your experiment. Of course, as you all know, because you are engineers, what is true for a small version of observations might not be true when you scale. And then other observations come and you can adjust your models. And this maintenance has to be considered on deployment. I have a question, I think. I will stop in 10 minutes and we will have an hour. Just to be sure that I close a batch and that we go to grab a coffee and then we go back with other things. So there are two things that that existing tools have in order to run experiments. Existing tools have to cope with tools that let you deal with the data, with all that I have addressed in these almost two lessons, okay? How to store it, how to archive it, how to maintain it, how to curate it, all these things. And then you have a second type of tools, which is the algorithms. Of course, we are not going to implement all the algorithms existing on Earth. There are already tools that provide us with the different algorithms, with different versions, with different characteristics. And this is given through other tools. And then we have to cope data curation, management, etc., with the libraries and in order to set our experiments, okay? Now, there are three experiment enactment environments, three types. there are tools that are focus a lot on the data management and preparation and things. They run normally integrating many tools that are already services on the cloud. So they are called big data platforms and stacks. They are deployed at different levels of the stack of the cloud. And they are provided to users like us in the form of virtual machines. And vendors have already prepared the tools that are intended to be useful for data science exercises, and they provide data science virtual machines. Okay, this is the example of Microsoft, but almost all vendors provide this kind of solution. So all the tools necessarily possible to be used for running data science experiments on virtual machines, okay? So that we don't have to install anything or whatever, it's all contained, self-contained. These kinds of solutions are normally more used for the second and third phase of a data science experiment. So when it scales and when it is deployed, okay? Because you need technical knowledge and skills in order, computing technical skills in order to use this kind of tools, okay? Now, for in-house solutions, there are what we call IDEs. And some IDEs run on your machine, or they also run on the web. And there they provide much more computing resources. They provide particularly libraries associated to programming languages in order that we can set our experiments. And then a third group of solutions are solutions that are an evolution of these and that integrate the two worlds, the data management world and the data analysis, data science world in one in and all, okay? And they provide also tools in order to do experimentation in-house, but also to scale at many different levels and also to do model maintenance, okay? So this is what we call machine learning studios, okay? There are, again, different vendors provide such kind of solutions, and it depends on your organization which vendor you are going to use, but normally the tools are quite similar. So I said this, and it's animated, but anyway. This is not of your of the idea. So what I'm going to do is the next step is, oh yeah, I forgot to say, what we're going to use in this lecture is here, okay? We are going to set in-house experiments using IDEs, so in all solutions that will be deployed not in our machines, but on the cloud, okay? So, and in this way, we will just focus on the experiment and on the running problems. That will be the focus of the experiments we will run today. So in the, we're going to do a break of 30 minutes, which is, we're going to meet again at 4:15. And we will have a try on such kind of solution with a kind of practical experiment so that you can see how this solution looks like. But for now, we are going to grab a coffee, a tea, or water, or whatever, and you can come back in 30 minutes. So 4:15, we start again. And now I'm going to stop registration. Okay. going to put this here. So. Okay. So we are going to start smoothly back to the last point I stopped on. As I said, the idea in this lecture is to use in-house prepared tools in order to set experiments and run them. Just let me put the Slack on so that, okay, so that people might ask questions. Okay. So any environment, in fact, for running experiments, until today, particularly in-house experiments, until today, we program. And you will see that even if we program, there are now tools that let us program in a very intuitive and easy manner, so that we struggle the less possible with technical aspects and with programming. I suppose that you have all had some experience with programming, and you know that it's sometimes a little bit cumbersome to run programs. But you will see that with the tools that we have for data science, this is not that cumbersome. This said, first of all, well, as I said, we need a programming language. What we're going to use in this lecture is Python, for several reasons, because Python has become a popular language, programming language, to be used in data science for running experiments. And also to show you an alternative. I suppose that given your background, many of you might have used MATLAB for running models. Supposing that you have had some experience, and if you haven't, don't worry. Yeah? But it's intended also to be a little bit complementary to MATLAB, and eventually in other lectures or in your past, you might have used R. R and Python, I would say that there you have similar solutions. Even if R is intended to have a whole environment, but Python too has a whole environment, yet Python is more comes from a computing science community where you run programs and eventually you can use it in order to go until deployment. Whereas R and MATLAB, you would have to have other layers, computing layers, in order to produce a final product, okay? So this would be the kind of difference regarding these tools. I don't know if you are acquainted with Glassdoor and these kind of sites where they provide you with hints about the type of interviews that you might have in industry when you want to postulate for a data science position or a data science related position. And if you go there and you're curious, you will see that in general, one of the questions is to discuss the difference, or whether R and Python are better or less better than something. There's good than something. And in fact, vendors and the data science community agrees to say that they can be equivalent, and that having skills on Python or in R can easily let you go to the other. So anyway, for these data science lessons, we're going to use Python, and if you are not acquainted with it, you will see that it's a nice tool to run data science experiments. So of course you have Python, the language, but what it is very, very interesting is that there is a whole community around Python that has developed, I would say that almost all algorithms and models that you can use for running experiments. Okay, so this is also a very comfortable thing because you have to know what you're doing, but you don't have to implement everything that you need in order to run experiments. So it provides particularly fundamental libraries for data scientists. And what you must know is that there are 5 basic libraries that Python provides for running data science experiments. First of all, NumPy. NumPy provides all necessary operations to play with matrices. Since you are engineering students, you perfectly know the importance of linear algebra. Okay, in many different problems that we address in engineering, we use linear algebra. This means that we operate particularly with matrices, and that we need to have tools that can let us play with them. NumPy provides all the necessary basic operations to deal with multidimensional arrays, which is the data structure that we use in order to program matrices. So there you have all you require, not only, of course, for your data science experiments, but if you are trying to program something using matrices, you have everything there to do that in a very easy manner. Second library that Python provides for data scientists is SciPy. SciPy, again, when we are engineers, what do we often do? We run numerical algorithms. So again, you have numerical algorithms already implemented that you can use for processing your data and running your models. It also provides domain-specific tools, particularly for signal processing, for optimization, and for statistics. So you see, you have really transversal mathematical tools that in general in engineering we use in order to address our problems. Then, as you have seen in the workflow, the data science workflow, and particularly if you have done statistics, there is a need of visualizing. And so Python provides a library with interesting tools. You must know that matplotlib is the very basic one. There are other more fancy libraries to produce fancier visualizations, but the very basic one is matplotlib, and it provides all necessary tools for data visualization. Then we come closer to other tools that are particularly used in data science, particularly machine learning tools. The families that the scikit-learn library provides is many different algorithms for classification. As you saw in my families classification with these little rectangles, classification was a topic, and it provides the tools for that. I think that I have a question on slide. Let me see. Yeah, but not regarding the other exercise. Okay, so you have classification. As I said, regression is a very powerful tool for running data science experiments, and it provides, again, different regression algorithms. And you can vary your functions, all the necessary to do regression. You can also have clustering. Clustering is the twin sister of classification. one is comes from a group of techniques called unsupervised learning, and the other is supervised learning. But we will see details during the lab. But anyway, you have these ways of classifying things and items, and you have all the necessary for doing that. Dimensionality reduction, also model selection, pre-processing, so everything you need to play with machine learning and company. I think I will have a question from Clement. I want to wait a little bit. There are neural networks with scikit-learn, and there is another one particular for neural networks, but there you have common neural networks models for playing with data science. Yes, and well, if since we are not addressing neural networks, but neural networks are more or less important, what I will leave as pointer is some examples of ways of simple ways of using neural networks for specific projects, and so that you can have a look on how it works for training and things like that. I will do that in order to give you a complementary vision of this, given the importance that they are acquiring. And then when you have seen, have had a first sight in Kaggle, but in fact, data science is just a consolidation of analytics that has been done for a long time ago in industry and many different arenas. So normally when people get these kind of data collections which are not well curated, they used to use Excel for addressing many projects. And in fact, why Excel? Because if you think about tabular data representation is very intuitive. It's a very nice way of representing observations, and it is also intuitive to play with it. Even if we do not have a mathematical background like linear algebra or things like that, knowledge like that, anyway, it's intuitive to work with it. And so a lot of data collections are represented in tabular manners. And when you play with table, that's one thing. And then there is another community that have worked a lot with relational databases. And there you have the notion of relation, and relation is a kind of table with particular constraints, but still you reason on tables. So what Python provides is a data structure, which is a table, and all the necessary operations to process tables. Which are these operations? For example, projecting, so getting a subset of columns out of a table. Extracting records given a specific constraint on values, for example. Making the union of tables, adding columns to the table. These kind of operations are provided by the pandas library. And this means that, for example, if you have CSVs, which are tables, as raw data, then you transform them to this to a tabular representation within Python, and then you play with them. And so with all the necessary to play with the tables, and particularly very useful when you start exploring a data collection. We will see in a minute how. So these are the 5 libraries that, basic libraries that Python provides in order to do data science. So for a fundamental knowledge about data science, you must know more or less how to operate with these 5 libraries and how to use them. Okay? So one of the objectives of the, of the theoretical, but particularly of the lab sessions that we will have is to show you this, the use of these libraries so that you end up with a first fundamental layer on data science using these libraries. But then, well, okay, you're happy, we have the Python, we have the libraries, but of course you need a running environment where you write programs on Python and then you run them and you see whether they work or not. And this, again, if you have programmed, I suppose that you have used integrated development environments, the so-called IDEs. So an IDE, what it provides is, instead of having to go and look for the different libraries regarding a language and then integrating them in order to write a program, what they provide is a complete one-in-all self-contained environment that prevents you from going back and forth looking for libraries, and so that you can program on the language. So there are different, and they are called the language with the libraries in the computer science and then in the data scientist jargon, they're called ecosystems. Okay, so what an IDE regarding data science would provide is the whole ecosystem required by data scientists in order to run experiments, well, to define and to run experiments, okay? So there are 2 different ways of using such a solution. If you are working on your, locally in your machine, you need to have tools in order to install such an ecosystem. And this is a bundle installation. And an example for Python, which is very well known, is Anaconda. So Anaconda provides the integration of all the toolboxes and things that you will need in order to work with Python and run your programs, okay? So this is one solution. And the other solution is, it sometimes happens that the way we organize our machines and we install applications and libraries, it starts becoming a kind of a mess. And so there are crashes between libraries and so on and so forth. So there are other solutions that prevent us of this burden of installation, and they are called, well, you have the IDEs, but particularly you have IDEs that run on the web. So you don't have really to have this, and more than the web, on the cloud, so that you do not have to install everything. You have the solution, you connect, and then you work. Anyway, so this, for Python and in general for data science, these kind of IDEs provide the following solutions. You are going, instead of writing a program, what you're going to write is notebooks. Okay, so they are based on the idea that you are going to have a notebook, and a notebook consists of cells. The idea is that you are going to go step by step. I said at the beginning of this lesson that the way we run experiments is going step by step and test and learn, okay? So you go step by step, processing your data collections, applying different operations, And all these steps, in fact, define the pipeline of an experiment, the different tasks that you perform in order to run an experiment. So there are cells that represent program, a bunch of, code that is applied to your data sets. And the second type of cells are textual cells. Why? Because as in any experimental science, you have the log of your experiment. So scientists annotate, I did this, I observed this, so these annotations are written in text, and so your notebook will include the cells that explain textually the log of your experiment, your observations, and the cells that really perform operations on the data collections, on the data in general. Okay, so you end up with an experiment log that includes everything, including results. And what is great is that you can share this. Okay, so you can exchange your experiments, and so others can reproduce them and can analyze them, and so on and so forth. Okay, so an experiment will be written in a notebook, and an integrating development environment will give you the tools to have these notebooks and run them. Okay. A very well-known environment for doing this is called Jupyter. Okay, and what we will use is Jupyter notebooks are the tools that we're going to use to express and run our experiments, and we are going to use a tool that will help us run this and interpret the notebooks written in Jupyter. So we're going to use Jupyter notebooks. So how do they look like? This is an image. In a minute, you will run one on your own. But as I said, you have, this is a notebook. It's a kind of HTML page. You have this text, which are markdown. Markdown is a textual format, okay? So you have textual things that explain, for example, what they did in this notebook. And then you have other cells, which are code. And here you have the results, for example, graphics of something performed on data. Okay, so this is the way you will write your experiments in this lecture. Now let's go and have a look on this. So for the remaining time of this lesson, we are going to go to prepare the environment and to do at least a first part of a first experiment that we will use to get acquainted with pandas, okay? So get acquainted to the way we deal with tabular formatted data. So I'm going to try to go very smoothly, because I have realized that if you are looking at me, you cannot be looking at me, looking at my web server, and then having your web server together. So I understand that these are not the best conditions for this, but well, this is what we have. And so I'm going to go very smoothly. And please, if someone stays behind, tell me, okay? Tell me, because it's very important that we all, at the end of the session, end up with on the same page, okay? We are not lost. So, first, I'm going to close Variant, and I'm going to go to the, so everyone please go to the to Google Classroom. And it's important to have the point here. We are in the second topic of the organization of the classwork material. We are going to start designing experiments. And first we're going to, we have, well, I have explained the tool that we are going to use, and we are going to have a try on using the tool. So when you have this notebook, it refers to an assignment, okay?
Excuse me.
Yes.
Your screen is not showing what you are doing. It's just stable.
Ah, let me see. Oh, you're right. Let me, I'm going to stop the sharing and share again to be sure. Well, I'm hesitating whether, well, I'm going to share my desktop and see. Well, now you see yourself and you see my browser. Now you can see my browser.
Yes.
Yeah, okay.
Thank you.
No, thank you for telling me. So I am on the Google Classroom site of the lecture. You go to classwork, and we are in the second topic of the content. And in the second topic, the third item is an assignment. It says getting started with the data science ecosystem. Okay. And there you have three general things to know. The first is that you all have done it because we did the first getting acquainted with Kaggle, and we got acquainted with Kaggle as a data lab. In fact, Kaggle is a much more complex environment, and it provides computing resources and the environment to run notebooks. Okay. And we are going to use this aspect of Kaggle in order to have this try. So what you need is have a Kaggle account. If you already have it, then you are ready to start the second point. If there is someone that doesn't have a Kaggle account, please go to HTTPS, well, click here and create a Kaggle account. Now, when you go to Kaggle, you will see that you have the possibility of dealing with your data collections. This is the aspect that we introduced in the first lesson. So you can have access to your to other people's data sets, and you can also have access to your own data sets. Okay, so I have assignments and from people here and so on and so forth. Okay, so that's when you click on data. And then you can click on notebooks, and it is the same principle. There are notebooks that have been shared by people working on running different experiments. And you can also have your own work. Well, I have my own work. You will have your own work later on. And you can share notebooks with people. In order to hand in, today, yes, particularly today, and then for the lab, in order to hand in your exercises, you are going to share your notebooks with me. Okay, so no need to upload anything anywhere. You will write your notebooks and then share them with me. And in that way, I will be able to go and see what you did and comment on it and so on and so forth. Okay. So this is the part that we are going to use, but I have prepared the whole exercise with the instructions in order to create your own notebook and run the exercise that we are going to perform. So in order to prepare your Kaggle environment for the exercise that we're going to use, you have to click on the second link of the assignment description. So I wait a little bit so to be sure that you went back to the classwork on Google Classroom, and that you can see prepare your Kaggle environment following the instructions, and then there is a link. And you can click on the link. Do I have a question? Yes, I do. No. Yes, yes, we can use either the chat, or you can raise your hand if you have questions. So I'm going to click on the link that says we have to follow instructions. I'm just giving time so that don't feel pressured. I can go back and forth. So if you click on the second link of the instructions, you will land in a page that says data-centric smart experiments, and it says getting started with Kaggle. The screenshots are a little bit different because Kaggle has evolved since I wrote these instructions, but you will see that you will get to use them. So the first is create a Kaggle account, but you have already done that. And then you are going to skip the part of the creating a data set, because that you have already done. We created the Game of Thrones data set, which is the first part of the instructions. So there you already know how to do it. And so we're ready for this. Now, for our experiment, we are going to see a new way of creating a data set. In fact, what I did for the whole lab, including this session, is I prepared all the data necessary that we will use for running different experiments. And this data, I stored it in a tool that you might know, which is called GitHub. GitHub is an environment for managing code. As you all know, when you program and you produce code, and you have your programs, and you have versions of the programs. And versioning a document is one thing, or versioning a data collection is one thing. Versioning a program is more challenging because normally programs use libraries, libraries evolve, they use versions of the libraries, and so it becomes a much more complex versioning to manage. And GitHub is a service that provides the necessary tools for dealing with code versioning. Okay. And it also gives you the possibility to have data associated to your code. So what I did is I prepared all the data that we need, and I put it on GitHub, of course, with a colleague. Okay, so you will see that it's not my name, it's the name of my colleague, but anyway, we prepared this. Okay, so we are going to get all this data and put it on our Kaggle environment. Okay, this is the first step that we are going to do. For that, we are going to I will show you a new way of extracting this data and put it into Kaggle. And this is done as follows. You are going to go, as you already know how to do, to Kaggle, but not this one, this is a notebook, and go to data, and you are going to have a new data set. And if you go to this new data set, this you already know, because this formula is the one that you used in order to play with the Game of Thrones data set. But when we did that, in fact, what we did is we took the data from our desktop and we dropped it on this formula. We're going instead to do the following. If you see here to the left of the formula, you have in fact different options to get your data collections. You can upload them from somewhere else. You can give it a link where your data reside. And this little cat represents GitHub. So since I decided to archive our data on GitHub, you are going to choose the little cat. And you land to a new formula. And as in the other exercise, you still have to name your data set as you want. You can say NC3, ICT, lesson, whatever you like. I have a question. Muhammad, yes. Okay. Do I have another question? No, I have. No, I have. Do I have a question on Slack? No. Okay. And then you have, so you name your data set, and then you have to give the correct GitHub URL where the data resides. This address is given here. So you have https github.com, and then the name of my colleague is Javiera Espinosa, and NC3 because we're working for NC3. So all this link, you have to put it on this formula. I'm going to NC3 2020. Okay, so in my case, I decided to name my dataset NC3 2020. I gave the address that I retrieved from the specification of the hands-on. And when I gave the URL, it went to GitHub and it already knows, it already presents all the files which are organized like in a file system. They are organized in chapters, of course, because we wanted to give an order to the data sets. So it presents what it's reading from this address. And then you can click on create. I'm not going to click on create right now. Those that are ready do, because if I have some questions, I can do a kind of checkpoint here. And if someone is struggling with something, please let me know so that we are sure that you get this step ready. Is everyone, if someone on the page, no? Are you lost somewhere? Sorry. So again, for those that might got lost, you go to data on Kaggle, you click on new data set on the upper right corner of the site. Once you have done this, you choose the cat because data is stored on GitHub. When you choose the cat, you name your data set, and the URL, you can get it from here, which is the second link that you can find on Classroom. So you have Classroom here, the assignment. The second link that we provided gets you to this page, and if you scroll, you will have the right address that you need to use, and you put it here. And once you have this view, then you click on create. Well, I'm going to click on create, given that I don't have questions. And well, at some point you get success, and then you go to the data set. And what you will have is, as we did for the other, the first data set of Game of Thrones, you will have all the description of your data set. Here we have many files, so you can have this little file system where it shows you folder per folder, what you have in each folder. You see you have many at some folders. So it provides you with all the organization of your data set. And it tells you that these data were retrieved from this address, and it doesn't have any description. You can add the description, etc. And it weighs 16 megabytes. But this, normally you have done the exercise for Game of Thrones, which is was a little bit dull. Now you have a more evolved version of creating a data set out of an URL that resides somewhere else. And then with a much more complex organization of files, but with the same principle. So this is the first part of the challenge. So,
sorry,
yeah.
GitHub, it's some sort of as well like a cloud, or
Yes.
what
In
makes
fact,
it different, and how can
yeah.
we upload this information to get it in the same way for another exercise or maybe a project we want to do?
Well, GitHub is a cloud service now, and it provides space for you to have either data and code. And you can have, you can put your code and your data in a project where you describe the project, you say if it's public or private, and then you can share your code with other programmers. So the kind of service it provides, well, the basic service is managing your code, the different versions of your code, eventually managing data associated to the code. And where it's the same principle as Kaggle, you can tag your code, you can have descriptions, but it's code. It's not, there's no notebooks, okay? And now it is a service from Microsoft, and so it resides on the cloud. So normally when you have a GitHub account, they provide you with the free version, they provide you with certain space so that you can upload your code, your data, and manage your projects.
Okay, thank you.
Mm-hmm. And now for the little history, now it provides other services. For example, you can host your web pages, your websites using it. And so this is a great question, because what we're using is two clouds. We are using the Microsoft Cloud in order to host the first raw material that we are going to use for our experiments. We are contacting that cloud in order to extract the data, and instead of downloading it on our machine, we are putting the data in another cloud, the Google Cloud, where we are going to host the data necessary to run our experiments. We are very fancy and trendy people here. Okay, so first thing, we have the data, but now, as we said, we're going to write experiments, so we have to go further on the exercise. Second service that Kaggle provides is dealing with notebooks. So we're going to create a notebook in order to start playing with our data. In order to do that, we're going to use the simple solution. If you see in the, after you have your wall image, there is a button saying new notebook. If you click on that button, what it will do, Kaggle will do, is associate all the data that we have uploaded to a notebook. So this is the easiest way to connect the data that you already have on the data lab of Kaggle with a notebook. Okay, this is the easiest manner. There are other manners, but we will start with the easiest one. Okay, so once you have your data uploaded, go to the upper corner of your of the space of your data and click on New Notebook. So I'm going to click, and if it once in a moment it does something, I don't know. Yes, and you will land to this kind of page. So we are going to configure we're going to set up the characteristics of our notebook. What you must know is that notebooks can be written in different languages. Okay, so Kaggle provides 2 languages. We can either write notebooks using Python, or we can write notebooks using R. In order to run programs, we can write our programs on notebooks, as we are going to do, and we can also write scripts. We are going to use notebooks, not scripts. Just to have the whole experience of these settings. In fact, as you probably know, Google has also a cloud with services. If you have an account on Google Cloud, you can link these services that you can access through your Google account to Kaggle. That's one possibility. We are not going to use Google Cloud, so we keep it in off. And then you probably know that CPUs are not the only processors that we can use in order to process programs. There are other processors with more capacity and other characteristics that let us scale on computing power. In our case, we're going to work with in-house solutions, so we will use CPUs with, we can say, normal power. It's certainly more powerful than our machines, but not that powerful, okay? But it is possible that we create notebooks with accelerators. So you can have GPUs. GPUs were popular for dealing with images. For example, if you are game players, GPUs were used in order to give you a good feel when you play games, okay? So these are for dealing with images, but in fact, they can be used to do other types of processing. So particularly for running experiments, they are becoming very popular and these are the GPUs. So it is possible to ask Google to run our experiments using GPUs, which will provide us with much more computing power. And there are other units which are tensor processing units. These tensor processing units are used when you, particularly when you play a lot with matrices and that you want to do parallel computing in matrices. And matrices are always very useful when you do deep learning. So those that were asking me whether we were going to use neural networks for our exercises, or that wanted to have a little bit of information about this, well, these networks are very greedy in computing power. And so it is popular now to apply this kind of algorithms and run them on top of these TPUs. So when we set a notebook, we can set our notebook and associate it to different architectures, physical architectures with different powers. So as I said, in our case, we're going to use normal CPUs, but be aware of this. Then how much? Well, we are using the free version of Kaggle. So we will have some power, but I mean, there is a limit. Eventually, people that are using the solutions in a professional manner, not in an academic manner, if you have subscriptions to the Google solutions, then you can define the number of GPUs, of CPUs, or TPUs that you can use for running your experiments. And this is configured in this easy manner that we are seeing now, okay? So for those that got a little bit lost, when I'm going to go one step back. So when you go to the data collection that you have created contacting GitHub, you in the page, on the page that you have this data collection, you click on New Notebook. You will land to this formula, this configuration page, where you are going to choose Python. You are going to choose, well, Notebook is chosen by default, okay? And then you click on Create. And you wait some seconds. And now, in the left upper corner of the page, you have Notebook and a number. You can rename your notebook. For example, I will say my notebook 1. I'm going to put my face out of here. And you will see that you have a first cell already filled in. Do not delete it. So if we analyze the page, in the left part of the page, you have the name of your notebook that you can define. You have a menu that we'll see in a minute. And then eventually when we will run, it will tell us our use of resources, CPU, RAM, and storage. We can stop the infrastructure. Once you create this, behind there, the Google has allocated servers that will be used in order to run our notebook, okay? So for the time, and they are running. So if we click on here, they will stop running, okay? So we stop consuming resources. And you have this right side of the site where you can add data. We will see in a minute. There's settings, and you can also have help for coding. Then here, this is important for handing in your notebooks. You can share the notebooks with someone, and sorry, it's just to tell me that we are running out of time. And you can share this with people. My ID is my Gmail account that you already have. And then you can version your notebooks. So you can version your experiments as I described previously. You can have different tries and different versions and deal with the versions, okay, with the experiments. So as I explained previously, you have cells. This is one cell, this is another, And then when you go to a cell, it asks you if you want to have a cell that will contain code or a cell that will contain text in markdown format. And then you can organize your cells in these little arrows. You can put a cell before another. And it is important that you understand that in order to run the notebook, you have to run cell by cell. Okay, it's interpreted. It's step by step. And the fact that you have to run every cell step by in order shows you that the principle of running this experiment is step by step, either manually or you can ask it to run it as in a batch, but it will always run cell by cell. Okay. So the first cell that provides, it's provided automatically by Kaggle, is in fact a piece of code that, first of all, imports two of the libraries that we are going to use. The NumPy for playing with matrices, linear algebra, and the pandas one that plays with tables. Okay. And then it provides a piece of code that will tell us where do our data collection files reside. Because at some point we will have to give it the address of our data and we need to write the correct path. Okay. So for running the cell, there is a little arrow here, a blue one. So you can run the cell. And what you have is the result of the paths of the different data that we uploaded. When you get here, you are ready to work on the lab. Okay, I think that we won't have time to, I wanted to have, let you have a first try on pandas, but this is not very important because we have the lab, and in the lab we will do that. But when you get until here, you are ready to start the exercises of the lab in the right session that you will have with me in smaller groups. But so that I can be sure that you get to the right a checkpoint regarding the preparation of your environment, what you will do is you will share with me this status. Okay, so if you click here, you can turn on the comments. You have to say that your notebook is public. And you can add me as collaborator. And so for instance, I don't know, let me, are you, yes. Are you on Kaggle? No.
Mm-hmm.
You see, for example, I have my colleague that has worked with me for preparing is here. So I can choose him to be collaborator. So if you click Genoveva Vargas -Solar, you will find me and you can share your notebook with me. So just to be sure that you will all on the same page for preparing the lab, I kindly ask you to share with me your notebook so that I can see that you have an empty notebook when you were able to run the first cell, and that shows that you have the data already associated to the notebook. I have some questions. How do we have the black screen? You run a file when you go to the, you click on the cell. Sorry, I'm going to, you click on the first cell, the one that was created automatically by Kaggle, and you click here on the little arrow. So just to explain, you can click on the arrow and run cell by cell. You can choose the arrow and choose this little arrow here, or you can ask it to run all the cells on top here. But the easiest way is that you click on the cell and the little arrow that appears in blue, you click on it, and then it provides the result in this black section. So that was for Fael. Fael, tout le monde. Yes, you can also, Roman started to answer, mise à jour plus enter in the cell, and it can also, it is a shortcut to run the cell. You can also, yes, Sami, you click on run and you play. Now I have an interesting question. It says, can you explain the main differences between Kaggle and Jupyter, please? Kaggle is the running environment with all the services necessary to deal with the data and with the installation of all the Python environment, plus the infrastructure, so the servers that can be used for running your experiments. Okay, this is what Kaggle provides, plus other things, okay? Jupyter is an environment that you can use only to run Jupyter notebooks on top of your, either on top of your machine or on a web solution. Kaggle is a set of cloud services in order to run different environments, including Jupyter notebooks. I don't know if, Mark, did I answer your question, or do you want to follow up? Everyone knows that who writes, sorry. Clicked on run, okay. Okay. So did everyone see how to share the notebook once you have run it? And of course, see that it's saved automatically, so the next time you will use your notebook, you will access it, you will access everything. And well, particularly for the type of laboratory and the type of format that we are using in this edition of the lecture, know that, it's quite practical to use such kind of solution, because I do not have to guide you for installation, for having all the tools, figuring out whether your machine can deal with the execution of the experiments, of the data, and so on and so forth. So everything is externalized on the Kaggle solution, and then we can easily use the infrastructure to run our experiments, okay? The alternative thing would be to install everything on your computer and then execute the exercises, okay? So We normally avoid this because we have 60 something people, so we don't have the human resources in order to help you with these technical issues in so short time. I mean, if we had a whole course, we might have this opportunity, but we have 8 hours of theory and 4 hours of practice. So if we lose time installing, then you don't see other aspects that are more important for the content of the lecture. So this is also a practical way of starting playing with the experiments and do not worry about much technical aspects. So we are getting to the end of the session. We still have some minutes if you have questions. I think that we must be proud today. We managed to prepare our Kaggle. We managed to get our data. We introduced the notion of experiment. There is, I mean, it's not rocket science. In fact, it's programming science. And this practical aspect, we will have the opportunity in smaller groups to do on lab. But for the time being, I think that you have the general overview of what is all about playing with data science and data with some tools, okay? And then we will go into the practical aspect with concrete projects. I thought that I was, I'm not sure if I am recording. Oh, yes, I'm recording, yeah. So again, for those that missed some part, I understand that there might be also connection issues. So as in the previous session, I will upload on my YouTube channel the session, and so that you can access it. You must share you only have to share the Kaggle notebook. As I showed, you click on share, you put it on public mode, and then you have collaborators, and you look for me, you search on Genoveva Vargas-Solar, and then I will receive a notification. And what I will check is that you all have this prepared, or if you have some issues afterwards, just to be sure that you are prepared for the lab. Agat, could you please add me on the? Yes, of course. Once we, well, I will do it now. I will right now, because, you know, I have still not the final list of the students. So I'm just I just have my own list that I prepared out of data collection. So do not think that I am excluding you if you do not receive the mails. It's just that I don't have any information about how to contact you. So I don't know if I'm still, am I still sharing or not? No, I stopped, somehow stopped sharing. Okay. So Agat, you are now on my list. So you will receive, you don't get the black screen. Do you have the, Ahmad, do you have this cell? Do you see this?
For me, I don't have the black screen. I don't have the results.
Yeah, because you have to run it. So my question is, do you have the first cell, this one?
Yes.
Okay, then click on this arrow, on the blue arrow on the left.
Okay.
And then you should have the results in black.
No, it's not coming out.
This might be because of the way you created your notebook. If you didn't associate directly the data collection with the notebook, the data are not connected together, and this is why it doesn't find any data connected to your notebook. What you can do is create a new one.
Okay.
So go to, sorry, I'm going to open, well, I'm going to use this. If you go to data, here in the left part of the corner, you must have a link on the data that you created by contacting GitHub. For instance, I named it NC3 2020. I don't know how you named it. Do you see your data collection?
Yes, I can see it.
Okay, so in the site of your data collection, you have the button New Notebook.
Yes.
Click on there. So we're going to create a new one. In fact, we're going to create a new one associated to this data. Okay. So you follow the instructions.
Okay.
Then you click, and again you can name your notebook, your new notebook, and now execute the first cell.
Yes, it's okay.
Now it works. Perfect.
Thank you.
You're welcome, Ahmed. Any other questions? I think the notebook has to be related to the, yes. Yes, you're right, Almudena. Okay, if there are no further questions, I'm going to stop here. So please stay tuned on Slack, because if I have more information about the groups and all this kind of organization, I will let you know, just to be sure that everyone will know to which group connect and so on and so forth, okay? So try to, from time to time, go to Slack. Anyway, I will contact you by email, but just to be sure that everyone will know to which lab session to connect in, and which date, because be aware that some dates changed. So we will work like this. And of course, as I said, I'm available anytime online if you have further questions. So I'm going to stop sharing my screen, and I'm going to stop the session. I thank you for your attention and your participation, and I'm looking forward to be connected with you